The polynomial will always represent a rational expression or a rational function.
We're starting 3.5, right?
Yes. Although I started last time with explaining what asymptotes were, I'm starting now from scratch, and I will get to asymptotes again in a few minutes.
Okay.
So we're going to look at only at three different types, of rational functions. There's more than that. However, only three. Good. So do you see any difference among these three? Let's analyze the first one. Anything stands out about the first one?
Variable, both have exponents.
Say it again.
I don't know if I said it right. Some squares are the different squares.
Correct. But if you look at this expression and compare it to this expression and compare it to this expression, they're all three are different. In which way they're different? No?
Is it because it's a quadratic divided by a quadratic?
Awesome. So that's pretty close. Same degree divided by the same degree. It doesn't have to be squared over squared. It can be cubed over cubed. It can be degree 1 over degree 1. Excellent. That's the idea. Same degree. Okay, what can you say about the second type? And I'm going to call this type 1. Any same degree over same degree, let's call it type 1 so we know what we refer to. Excellent. Second one. So obviously we know it's all about degree. The second one says what?
It has one term over a quadratic.
It has degree 1 over degree 2. So we will say this is type 2, higher degree where? In the excellent. In the denominator. And obviously type 3. What will you say about type 3?
The higher
Degree.
lower part in the numerator.
Higher degree in the numerator, but exactly this time, this is specific. Degree n plus 1 and degree n. So this specifically says 1 degree higher in the numerator. Not by 2, not by 3, not by 4, but by exactly 1. So if the degree at the top is 2, this is 1. If this is 5, then this is 4. If this is 10, and this is 9. Okay. So let's start with the first one. So the first example, type 1. Let's choose, let's say, f of x equals x plus 1 divided by x minus 2. There is a long list of items that we have to go through, and I will list them on the test. You will not miss anything. Step number 1, what do you think it is? Like always.
Isn't that in a simplified version?
When we are asked, so the question is graph.
Oh, sorry. I thought we were trying to.
That's what we are trying to do. We are trying to see how a rational function type 1 looks like.
So would we just plug in values for x and make a table?
We will make a table. We will summarize all the information in the table. But what is the first item that for which we cannot start, without which we cannot start? Whenever we graph a function.
You do the x and minor stuff.
Yes, that will be 2.
Found the dome.
Excellent, indeed. We always start with the domain for any function, no matter what. Very good, awesome. Let's look at this function and say the domain would be, we had this before when we solve rational equations. So please don't rush and tell me what is the domain.
Negative infinity to
Very good, awesome. Can anyone explain to everyone else why?
Because your denominator can't equal 0.
Yes, we know that x minus 2 cannot equal 0, x cannot equal 2 from chapter 1 when we solve rational equations. That was one of the reasons why I kind of forced you to state the restrictions, right, for this. So we don't forget how to find the domain. Very good. So I'll get my table going, and then I'll continue with the list. So here it is, negative infinity to infinity. Remember, in every table, I have to have 0. In this case, what do I put under 2? Exactly. I cannot put anything. There is no number that I can put under 2 because the function, you already told me it's undefined. If it's undefined, there is no number, right? Very good. Let's make ourselves a note. We discussed it last time, and now it's the time to discuss this again. Note, at x equals 2, function is undefined. X equals 2 will be a vertical asymptote. I will put in parentheses. There is one exception, though, with one exception. What is the exception? If x minus 2 is a factor at the top and x minus 2 is a factor at the bottom, and something else. So a rational function is undefined. In this case, a rational function is undefined at 2. X equals 2 will be a vertical asymptote, and we write VA. What is a vertical asymptote, if you remember? It's a vertical line that the function will never cross, and we will have to graph it. Bear with me. As you know, the first example takes like forever, and then the next and the next will take 3 minutes. There is no x minus 2 and x minus 2 factor top and bottom. X minus 2, there is no factor of x minus 2 at the top. So this is not an exception. This is very clear that x equals 2 will be a vertical asymptote, VA. Vertical, x equals 2, vertical asymptote. In the next step, so this is, we just determined the domain. Step number 2, so also with the domain, if you want to clarify, this is step number 2, vertical asymptote or vertical asymptotes were determined. In step number 3, I will find what it's called behavior of f of x near x equals 2, which is the VA. What are the possibilities? Here are the possibilities. Here's x equals 2. Here's x equals 2, the vertical asymptote. Here's x equals 2. And again, x equals 2. There are 4 possibilities for this function. Infinity and infinity. Negative infinity, negative infinity. Positive infinity and negative infinity. Negative infinity and positive infinity. And how will I determine this? Very simple. Very simple. Okay? So when x equals 2 is a vertical asymptote, I can already state that left and right the function will go to infinity. I don't know the sign yet. Remember, there are 4 possibilities. Both sides positive, both sides negative infinity, and so on and so forth. How will I know? I will use a number very close to 2, like 1.9. Notice that I do not put it in the table. I'm not going to determine anything other than the sign. And on the other side of 2, 2.1, these 2 numbers, for me, are close enough to 2. I cannot use 1 or 5. They're too far away. But 1.9 and 2.1 are close enough. So let's plug in 1.9 in the function. Don't calculate anything. I only need this sign. 1.9 plus 1, sign. 1.9 minus 2, positive over negative. Excellent. Sure. 1.9 plus 1 is positive. 1.9 minus 2 is negative. Positive over negative is negative.
And the next one is both positive.
Yes, 2.1 plus 1 is a positive number. 2.1 minus 2 is a positive number. Positive over positive will be positive. That's all I need to know.
So you get the first multiplier and then you're
I evaluated the function. I plugged it in. 1.9 plus 1 gave us a positive number. 1.9 minus 2 gives us a negative number. Positive over negative is negative infinity. That's all I did. I just replaced it in the function to get this sign where the function is going. It's the first example. Bear with me. When we get to the next one, you'll see how easy.
So you did all this
Because I needed to see which situation that is. Both sides positive infinity, both sides negative infinity, positive negative, or negative positive. So I established that it's negative infinity and positive infinity will look like this. Negative infinity and positive infinity.
and you did the 2.1 at the denominator.
I have to be, no. I plugged in 1.9 everywhere x is, and later on, I plugged in 2.1 everywhere x is. I cannot plug in 1.9 at the top and 2.1 at the bottom.
So because the last example,
These numbers?
no, it's not the last one. You said it was negative positive.
Negative infinity.
Right. So
On
what before that? What is that?
this one?
Yeah.
Positive infinity would have been positive infinity, and negative infinity would have been negative infinity. I was just listing the possibilities. We don't have to choose from these. Whatever we get, that's what we use.
Yeah.
But I was just, yeah, that's fine. But I was just showing what are the options for this function. In this case, it will be this option. Because it's negative infinity and then positive infinity. Next step. It's number 4. X-intercepts. How do I get the x-intercept for any function?
You subdivide.
Good, which is x plus 1 over x minus 2 equals 0. When is the fraction 0?
If the top is 0.
Exactly, only when x plus 1 is 0, which means x equals
1. Negative 1.
perfect. So negative 1 comma 0. Is this clear for everyone?
Set y to 0 and then
A fraction is 0 when the top is 0. So x plus 1 is 0, and we solve for x. Number 5, the y-intercept. How do we get the y-intercept for any function? Very good. Let's find f of 0. Let's do this together. 0 plus 1, 0 minus 2.
negative 1.
Excellent.
Oh, sorry. You said 0. So can you go back to that?
I just plug in 0. I evaluate for x equals 0. 0 plus 1 is 1. 0 minus 2 is negative 2. 1 over negative 2 is negative 1/2. So I put it in the table as 0 comma negative 1/2. Is this okay so far? Okay. Next step, number 6. And behavior and horizontal asymptote. Let's make ourselves a note. Type 1 rational functions, note. Type 1, what do we mean by type 1 again?
We do the same
Degree over same degree. Excellent. Type 1 rational functions have horizontal asymptote. That is, y equals leading coefficient over leading coefficient. Let's go back to our function. What is the leading coefficient of the top?
positive
1. What is the leading coefficient of the bottom? 1. So then the leading coefficient is 1 over 1. So then y equals 1 is the horizontal asymptote and behavior. So I write 1 and 1, and I write myself a note. y equals 1 horizontal asymptote. That's all I need. I'm ready to graph. The only one item that I did not mention here is symmetry. The function has a horizontal asymptote at 2. It will not be symmetric no matter what. But I should write f of negative x does not equal f of x. If it were, what we would have known about the function? If f of negative x equals f of x, what is that function? What is the property of that function? It's symmetric, but which kind? Even. But it's not. What about f of negative x not equal negative f of x? If they were the same, what type of function would have been?
You'd have to put like an odd.
Very good. Symmetric with respect to the origin. So it's not symmetric. Not symmetric. Okay. So let's make sense of the information we have. And let's give it a shot. Another note for you, please. When we graph functions with asymptotes, we must graph the asymptotes first. Always. Note. Graph the asymptotes first. Always. So I don't need any information. All I need is my table. Does this function have asymptotes?
Yes.
If you say yes, then I'm going to plot. What do I have to plot?
X equals 2 is vertical.
X equals 2. Do not graph them as solid lines. They're not solid lines. They are just helping us keep the graph or have a correct graph. What is the second asymptote of this? Is there anything else?
Y equals 1.
Very good. Here's y equals 1. Is the whole. Another note, please.
Oh, you're reading.
Just 1 second. I just want to add a note and I'll come back. Another very important note. A rational function can cross a horizontal asymptote or slant. We haven't talked about those yet. Slant asymptote, comma, but never, what do you think?
Never vertical.
Exactly, because it's undefined. Awesome. It can cross a horizontal asymptote. It can cross a slant asymptote, but it will never cross a vertical asymptote. Excellent. Well done. Because the function is undefined there. Okay, so it can cross a horizontal or slant, but it can never cross a vertical. Good. Very good. So now let's take a look at the table. I'm going to try and make sense of the information I have first. So a horizontal asymptote is this line, right? So let's see what we have. It's coming from 1 to negative 1, 0, this point, crossing at 0, negative 1/2 at this point, and going to negative. One more time. From 1, crossing at negative 1, 0, crossing at 0, negative 1/2, and going to negative infinity on the left-hand side of the vertical axis. On the other side, it's coming from positive infinity and approaching 1. And that's it. So I have to plot negative 1, 0. I have to plot 0, negative 1/2. I already know what's happening here on the left-hand side. This is the graph. And I already know what's happening on the other side. And this is the function f of x equals x plus 1 over x minus 2.
Okay, so we don't have to, you wouldn't label each line, you would just label.
I did label them. I did label them. This is x equals 2.
Oh, no, I meant like your curved line.
Yes,
Because that's just.
but this is the function.
So as long as you-
So this is the function, this and this.
Okay.
Can anyone give us the range of this function?
Negative infinity to 1.
Very good.
And then
Union.
1 to
1 to infinity. Excellent. Imagine that you cross it with horizontal lines and you cannot cross anything here. At 1, the function does not there, right? And everywhere else. Excellent. With the graphing calculator, in case you want to check, let's do that. Yes? Any questions? In Y? Yes?
How did you put range again?
From the lowest Y value to the highest Y value, and it has a gap at 1. So in Y equals, please, when you enter rational functions, you have to put parentheses. So the top is x plus 1 in parentheses divided by, in parentheses, x minus 2. The graphing calculator is not as smart as you are. So in other words, it does not know that there is a horizontal asymptote. You have to put it yourself. What is the horizontal asymptote?
The horizontal is y equals 1.
Correct. Okay, it's coming. So let's use the zoom 6, the standard viewing window. So it's coming from 1, crossing at -1, 0, crossing at 0, -1/2, and from infinity to 1. And this is the horizontal asymptote. Now you see, I don't know how to present a vertical asymptote with the software. Most of your calculators should present the vertical asymptote and positive too. I'm not sure how to do this with the software. My apologies. Good. So this is a rational function. Now the second type is much easier than this. I shouldn't say much. It's even easier than this. What is the difference between type 1 and type 2? Is the fact that the horizontal asymptote will always be 0. Note?
For type 2,
Yeah, always. Type 2, rational function has y equals 0, horizontal asymptote always. Oh yes, of course, I'm sorry. Sorry. That's the only difference. So let's take a look at an example. Say it again.
the type 2 rational function has y equals 0 as a horizontal asymptote function.
Again, careful with the method in the book. I don't have anything against it, but they are just dumping stuff on, and listing stuff without summarizing it. So they just have some points here that they present. I have nothing against this method, but it's difficult to put everything together. But if you summarize everything in the table, it's always the best. So look at example 6. They go on and on and on with all these steps that I already presented to you, but they don't summarize the information anywhere. There is no table. Really, this is just nothing. So I'd recommend using a table or make up your own and summarize the information, because it will be difficult to graph. Yes?
What was that range again? It was negative infinity to 1, and then because of the break,
Yeah.
it's positive. I mean, it's
So let's look at the graph one more time. The function exists. Yes, yes, yes. No, the function does not exist when y is 1. And then it starts existing again. So negative infinity to 1, union 1 to infinity. So let's take a look at a rational function of type 2 this time, which will be much easier because we already know type 1. So let's say 59, I picked 59 on page 427, and the function is f of x equals 2x over x squared minus 4. What type is it?
Is the type 2 with the degree higher?
Higher in the denominator. Very good. So let's get the table going from the beginning, and please tell me, and now you will see, you don't have to list anything, what will be the domain of this function? And you can say, not yet, I need to do something before I establish a domain. So what do I need to do? Awesome. Of course, yes, I have to factor the denominator. That's how we did on chapter 1. In chapter 1, when we solve rational equations, exactly, it's the same thing, same function. But then I didn't tell you what it was. We only said it's a rational expression, but it's also a function. So can anyone give us a domain?
Negative infinity to negative 2, and then negative 2 to 2, and then 2 to positive infinity.
Excellent. So then I know that x equals negative 2 is
Vertical asymptote.
x equals 2 is a VA. Remember, only if x plus 2 is not simplifiable, and it's not. There is no x plus 2 at the top. There is no x minus 2 at the top. So they stay. What do I have left and right of the vertical asymptotes always, forever?
Oh,
Definitely infinities. That's the concept of a vertical asymptote. I will pick negative 2.1, negative 1.9, 1.9, and 2.1. Why am I picking those numbers?
Because of the closest.
Because they are close enough. They're close enough. And what am I testing with them?
what degree is it? Oh, to see the
The
behavior.
sign. The sign. That's it. That's it.
So if you're opening us to always choose them to like, we got same rules for, I would do 3.1.
Exactly. That's close enough. That's close enough. Yes. Okay, so let's plug it in. Do not calculate anything. Just give me the sign. Negative 2.1 times 2. Just the sign. Excellent. Negative 2.1 plus 2. Negative. Negative 2.1 minus 2.
Negative.
Excellent. 3 negatives.
Negative.
Excellent. We move on to negative 1.9. 2 times negative 1.9. Just the sign. Careful. Negative 1.9 plus 2.
Positive.
Excellent. Negative 1.9 minus 2.
Negative.
But now we have 2 negatives.
Positive.
Excellent.
So 2 negatives and a positive is positive.
Yeah, we're positive, so we don't even count.
Correct.
Yes. 1.9. 2 times 1.9.
Positive.
1.9 plus 2.
Positive.
Careful. 1.9 minus 2. 1 negative. Finally, 2 times 2.1.
Positive.
2.1 plus 2. 2.1 minus 2.
Positive.
Done. What did we say the end behavior would be for type 2 always?
Oh, the 0.
Very good. Y equals 0 is a horizontal asymptote. When x is 0, how much is the function? 0 at the top and negative 4 at the bottom.
So negative 4. Wait, 0 at the top. Oh, it's 0.
0, very good. Well, it happens that this function is symmetric. Because, and I will always check when I see two vertical asymptotes that are symmetric. Negative 2 on one side, positive 2 on the other. F of negative x, the denominator and the numerator, I have to plug in x. Negative x. 2, negative x squared minus 4. I have to determine symmetry. I plug in negative x in the function. It's this concept. Yes. So let's go back for a second. I plug in negative x to determine whether the function is even or odd. And I have to calculate that. So 2 times negative x is negative 2x. This has no change. But if I take the negative in front, and I should, then I realize that this is the opposite of f of x. This is f of x, and this is the so the function is f of negative x equals negative f of x. Good. So before I graph, I'm done. So it took us 15 minutes for the first one. It took us 3 minutes for the second one, right? So let's see what we have here before we graph it. From 0, which is the horizontal asymptote, to negative infinity on the left-hand side of the first asymptote. From 0 to negative infinity. On the other side, from positive infinity, it crosses at the origin and then goes to negative infinity on the left-hand side of the next asymptote. Here, from positive infinity to 0. One more time. From 0 to negative infinity, from positive infinity to the origin and going to negative infinity, and then from positive infinity to 0. Quite easy, I would say. So when we graph a function with asymptotes, what do we what must we graph first?
The asymptote.
The asymptotes, very good.
Now, when the horizontal one is on the origin,
Very
we
good.
just write it like
Yeah, it's
y
an
equals 0,
it will be an overkill if I do this, but I will do it just to make sure that we all see it. Then at -2 and at +2, yes. Very good point. X equals -2 and x equals 2. All I need is this table. I don't care for anything else. Ready? So from 0 to negative infinity, here it is. From positive infinity to negative infinity, passing through the origin. And on the other side, from positive to 0. So this is the function 2x divided by x squared minus 4. And this was type 2.
So for type 2, do you normally not find the intercept?
Very good question. The numerator, for the x-intercept, the numerator is 0. Well, 2 times x is 0. It must be when x is 0.
And then y equals 0 is the horizontal asymptote.
It's the x-intercept and the y-intercept at the same time. Yes, I always do, for all of them.
It just so happened it was
It just
0.
happened for this one was easier, yeah. Thank you. I can't get away with anything in this class. Thank you, I don't even want to. Excellent point. Okay, let's look at some word problems to see why we're even discussing rational functions. A lot of applications. Let's take a look at this. So here's a function, and this is problem 101 on page 428. 101 on page 428. We're given a function. Let's look at the function first. It's right here in the balloon, wise balloon, whatever you want to call it. What type of rational function is this? Obviously, it's a rational function. Exactly. Why is it type 1?
Because
Same degree over.
same degree.
It has a horizontal asymptote. Is it 0 or something else? Something else. What is the leading coefficient of the top?
6.5.
What is the leading coefficient of the bottom?
1.
So what will be the horizontal asymptote then?
6.5.
Right. We see it here,
Oh,
No.
right? 6.5. Okay. So now let's read. We know it's type 1. We know it has a horizontal asymptote. We know that possibly x has some sort of value that starts at 0. It's nothing to the left-hand side of 0, no negative number. Well, let's see what they want. Ready? It models the pH level f of x of the human mouth x minutes after a person eats food containing sugar. The graph of this function is shown below. Okay? So here's the graph. Even if we don't know how to graph this function because we just study that, it's first of all, it's graphed for us. Secondly, we know it's type 1. And we know it has a horizontal asymptote, which is 6.5. Excellent. Part A. Use the graph to obtain a reasonable estimate to the nearest tenth of the pH level of the human mouth 42 minutes after a person eats food containing sugar. So if we take a piece of sugar now and we swallow it, 42 minutes later, right, something happens with the pH in the mouth. I'm not a physician, so I can't tell you details about that, but they came up with this function. So they said 42 minutes later, so the pH level, as you see, we can interpret this very easily, but let's not do that just yet. So 42 minutes later, the pH level is 6. Okay, part B. After eating sugar, when is the pH level the lowest?
6 minutes after.
Yes, so the pH level must must be normal at 6.5. It drops rapidly. Take sugar. It drops rapidly in 6 minutes. It gets the minimum, according to the function, it gets the minimum of, what would you say, 4.75 roughly, maybe 4.8? Okay. And then what happens with the pH level?
Like,
Yes, so it drops dramatically in the first 6 minutes, but then it recovers. But it takes a long time to recover. Even 6 to 6 minutes till it gets back to normal. Okay, so according to the graph, what is the normal pH level of the mouth?
6.5.
Correct. What is the equation of the horizontal asymptote? Y equals 6.5. Use the graph to describe what happens. We already did. Okay, next one. A drug is injected, 102. A drug is injected into a patient, and the concentration of the drug in the bloodstream. So if you see carefully, look at this. These functions are way more sophisticated than simple x squared or simple trajectory when I throw up in the air, up and out a ball, right? This is way more sophisticated, right? So can anyone tell us what type of function is this? Obviously rational, a polynomial. Yes, it is type 2, which means the horizontal asymptote is 0. Very good. So the graph is shown. So here's the graph, here's the function, it's right here also. Use the graph to obtain a reasonable estimate of the drug's concentration after 3 hours. So the patient is injected with a medicine, and he does not have this medicine in his bloodstream, assuming, and is injected here. The concentration increases fast, right? I don't know how many minutes, maybe this is just 1 minute. I don't know. I haven't read everything. I have to read this information here and see how big is the tick, right? So it shoots up, and then eventually, and we hope that all things that we swallow, sugar, medication, we hope that eventually the concentration in the bloodstream goes where? We hope it goes away.
Goes back down.
We hope it goes away, right? We take medication and we hope it eventually will go away. Goes to 0. Okay, so use the functions equation. Okay, use the functions equation to find the horizontal asymptote. I don't need to use the function equation or do anything else. I know it's type 2. It must be the horizontal asymptote must be 0. Y equals 0. That's it. So here's another. Here's another application. And this is problem 103 and so on and so forth. So let's just read it. So the question is, so what type of function is it? Right. It is type 1. What would be the horizontal asymptote? What is the leading coefficient of the top after you distribute 100? 100, right? 100. What is the leading coefficient of the bottom? 1. So what would be the horizontal asymptote? Exactly. 100 over 1. Very good, which is 100. So let's see what they want with this function. It models the percentage of smoking-related death among all death from a disease. Okay, so let's just find 103. Find P of 10. So let's look at what it says. So what is this? The disease incidence ratio. The number of times more likely smokers are than non-smokers to die of a particular disease. And over there, percentage of death. So we're asked to find P of 10. So what is P of 10?
90.
So I would say 90. So the incidence, so the percentage of death from the disease that are smoking related, it's 90%. By the incidence ratio of 10, at the incidence ratio of 10, a smoker is 90% more likely to die of a particular disease. It may be related to smoking or not, but the body, I guess, weakens. Any questions about rational functions? And if you say, well,